Okay, so we are now on page 456. We're in the middle where it says indeterminate forms, and the forms, as you can see, are very different. Okay, you have this guy, and then you have this guy, and then you have this guy. Okay. So the interesting thing is that everything we've talked about so far was either this or this, really. There are only these two that we talked about. You know, what can you see that's different here? Okay, these do not have anything in the exponents, right? These have all things with the exponent, which means that you have an x or something of the function in the exponent and something down here also, okay? So when that happens, you're going to do the one in the green. So read the green box in there. It tells you what to do. Okay, so when you have something like this, basically, as the green says, you're going to try to find the limit of, let's say this is going to 0. You're going to try to find the limit of the natural log of the function. Because what you're really trying to find out is this guy. What you're really trying to find is this guy, right? But since I have an x in the exponent, by taking the natural log, that takes care of that because that comes back forward now because it's underneath a natural log, okay? So basically, I'm going to find this. And what this tells me, if this is going to be, if I find this as being L, what I'm trying to find really is this guy. And what I'm going to say is that I'm going to say that this is the same as e to the natural log of f of x, right? Because I have e, but then I have the natural log here. So basically, this becomes f of x, okay? But I know where this guy goes. I figured that out, and I found this is L. So this guy is going to be e to the L. Can you see that? So it's a roundabout way. Okay, we're trying to find this, but we can't find this because it's in this form. So what I'm going to find is the natural log of f of x, the limit of that. And then I'm going to put it in here and say it's e to the L. Okay, so let's go ahead and actually do one of these. When I do one of these, it becomes a little easier to understand. So we have example number 8. Example number 8, I have find x going to infinity 1 plus 1 over x to the x. And so as x goes to infinity, this guy goes to 0, so I get 1 to the infinity. It's basically 1, right? So the answer seems to be, or you could think that it's 1, but it's not. Okay, right? Again, so since I cannot find this, this is in this form right now, 1 to the infinity form. I'm going to go ahead and call this f of x. And now I'm going to try to find the limit as x approaches infinity, the natural log of f of x. Okay, so I'm going to try to find this first. Okay, so if I take that, what do I get? I get limit as x goes to infinity. When I take the natural log of this, I get x natural log 1 plus 1 over x. Do you see that? Right, because when I take the natural log, the x comes forward, right? Okay, so I get this. And this is the same as x goes to infinity. Natural log 1 plus 1 over x over 1 over x. I'm taking this guy and putting it down underneath here, so that's 1 over x. Okay. So now x goes to infinity. This goes to natural log of 1, which is 0, right? So this is 0, 1 over infinity. So this is 0 again. So I get the good old 0 over 0. So now I can take the derivative of top and bottom. So we take the top derivative of the top. I get what? 1 over 1 plus 1 over x. Right? And then I have to take the chain, so we have to do the chain rule, right? Let's take the chain derivative of in here, which is going to be negative 1 over x squared. This guy, if I take the derivative of this, I get negative 1 over x squared. Okay. So I multiply top and bottom by x squared. Comes this. So this goes away. It's basically 1 over 1, right? So basically I get limit as x goes to infinity. This becomes what? 0. So basically I get 1. 1 plus 1 over 1. No, 1 times 1 over 1. So this basically becomes 1. You see how that became 1? Did I go too fast? I think I went too fast. Let's just take the derivative of this, right? The derivative of this is 1 over this. The chain rule says I have to take the derivative of this inside here too. So I have to take the derivative of this, I get negative 1 over x squared. Okay. I can take the derivative of the bottom, which is again negative 1 over x squared. Okay. This guy and this guy cancels out. So now I'm going to go limit as x goes to infinity, 1 over 1 plus 1 over x. X goes to infinity. This guy goes to 0. 1 over 1 is 1. Now notice, I have not found this guy, the limit of this guy. I found the limit of this guy, right? Natural log. So in the end, what I'm trying to find is f of x. This is what I'm trying to find. But what I found right? What I found was that this guy here goes to what? 1. So this guy here is going to be, does that make sense? Okay. So the answer is E. Okay. Let's try one more. Example number 9. Determine x to the x. X to the x. And see if it does exist. Okay, so again, this is going to be, I'm going to say that f of x equal x to the x, which means that natural log of f of x is going to be equal to x natural log of x, right? Because the x comes forward, I get that. So I'm going to try to find natural log of f of x is going to be equal to x goes in this guy, x natural log of x. Again, I'm going to go ahead and manipulate this and go like that. So when x goes to 0, this guy goes to what? No. Natural log goes like this, right? 1. So as x approaches to 0, it goes negative infinity, right? It's going to be negative infinity. This guy's going to be positive infinity, right? So basically you have an infinity over infinity thing, right? Which was one of the forms in L'Hopital rule, right? doesn't matter what it's negative or positive. So now I can go ahead and take a derivative of top and bottom. So I'm going to get natural, and this guy, take a derivative of this, I get 1 over x. Take the derivative of this, I get negative 1 over x squared. To multiply x squared to top and bottom. I get x over negative 1. Correct? So when x goes to 0, this guy becomes 0. Right? 0 over 1 is 0. This one's 0. So again, I know this. But what I'm trying to find, again, is this. But what I found out was that this guy here goes to 0. Since this guy here goes to 0, this guy's going to go to that, which is 1. So your answer is 1. Okay, last but not least, we have one more to do, which is similar to what we just did. So example number 10. You're trying to find as x goes to infinity, x 1 over x, which would be infinity to 0 form. Okay, so I'm going to go ahead and call this guy f of x. I'm going to find that natural log of f of x is going to be equal to 1 over x, natural log of x. I'm going to go natural log of f of x is equal to x goes to infinity, natural log of x over x. As x goes to infinity, this goes to infinity, bottom goes to infinity, so you have infinity over infinity. The form that you can use the L'Hopital rules. I'm going to take the derivative of top and bottom. Derivative of this is 1 over x. Derivative of that is 1. So basically end up with 1 over x. X goes to infinity. That goes to 0, right? 1 over infinity is 0. So this guy goes to 0. So limit as x approaches 0 and infinity f of x is the same as e to the natural log of f of x. But I just found this guy goes to 0. So this guy's going to go to that, which is 1. Okay. All right. We are done. We are absolutely done, which means that we are done